Okay, let's take a look at this. What net force would accelerate? 0.14. This is, I'm just guessing that this is the distance that a pitcher uses to speed up the ball, right? Might be longer than that, right? They have quite a windup, but let's see. Okay, we have a final velocity, an initial velocity, and a distance, right? And we don't have an acceleration, and they're asking for force, right? So we know ultimately that the answer is going to be, we're going to go F equals ma, and that's going to give us the ultimately that's going to give us our force, right? But we don't know what the acceleration is, right? So let's figure out the acceleration. This is one of those Subat first ones, right? Okay, let's see. If you know the force and the mass first, and then they ask you some Subat question, you do this first. But if you don't know the force and the mass, or the mass and the acceleration, sorry, then you do this first. So let's look for the acceleration. So let's see, rest is 0. This is our final velocity. This is 0.985. We want a, so we'll use no t, right? Okay, 38 squared equals 0 squared plus 2 times a times 0.985. Okay, so a is going to be 38 squared divided by 2 times that's quite an acceleration. 732.99. I don't know if that could be right. That's like a lot. That's like like 73 G's. Of course, you know, this is why pitchers can only pitch so much, right? And otherwise they'll injure their arms. Okay, and now we're set, right? The force is going to be ma. Why did I write it again? I don't even know. Okay, F equals 0.145 times 732.99. So literally on my calculator, I'm just going to go times 0.145. And I get 106.28. Which with 3 sig figs would just be 106 newtons. Wow, that's a lot. How many pounds of force is that divided by, let's see, pounds. What are pounds? 4.45 or something like that. It's like 24 pounds of force, I suppose. Could be, right? You could exert that force with your hand.